Welcome to part 2 of the Module 10 Statway video. Next, we're going to look at paired differences of data. This is where you might have a person, in this case we have children, and we're looking at two methods of measuring their blood pressure. One of them called the Finnepress method, the other one the catheter method. Now, just like we did when we had multiple populations and we were looking at proportions in Module 9, here, when we have two sets of data, we're going to be looking again at the differences of the data. Now, the order of subtraction has to be given to us, so we know what order to do the subtraction. So again, we have 15 children, and for each child we have two sets of data. The blood pressure using the Finnepress method, the blood pressure using the catheter method. And we come up with 15 differences here, Finnepress minus catheter. The next thing we're going to do is, we're going to take that information and we're going to put it into the TI, not the Finnepress data, not the catheter data, but the differences of the two measurements. We're going to put it into our TI in a list. Then we're going to do one var stats, and we're going to get X bar and S. So here, X bar is negative 2.93. That's using one var stats. S, the sample standard deviation, is 8.57. Okay, next, if we wanted to construct a 95% confidence interval for this data, since we have 15 children, 15 sets of data, the degrees of freedom is 14. The confidence level is 95%, so our T critical value would be 2.15. The margin of error is the T critical value, 2.15, times S, 8.57, over the square root of n, 15, 4.76. So to get the 95% confidence interval, it's the difference of the bars. It's the mean of the difference. What was the mean of the differences? Negative 2.93. So the mean of the differences minus the margin of error, the mean of the differences plus the margin of error. So that goes from negative 7.69 to 1.83. Now, can we say that the two measurement types give us different values? No, we can't say that because 0 is included in the interval. A difference of 0 means the two methods are giving us the same measurement. So we cannot say that one method is different than the other. The next thing we're going to do is we're going to look at hypothesis tests when we have paired, okay, so the next thing is we're going to look at hypothesis testing. Now, the null hypothesis is always the mean is a certain number. The alternative hypothesis is the claim we're investigating, the claim that we're hoping to prove. So again, just like we had with population proportions, you could have a left tail test that's less than, you could have a right tail test, or you could have the two tail test. Let's look at an example. Imagine a company sells portable walkie-talkie radios to construction crews. The batteries for these radios last an average of 55 hours. The purchasing manager for the company receives a brochure in the mail that advertises a new brand of battery. This new brand of battery is cheaper than the brand the company is currently using. However, the purchasing manager is concerned that the cheaper batteries may have a shorter average battery life than the one they're currently using. Okay, and by battery life, we mean the number of hours that batteries last. The pricing manager wants to perform a statistical test at the 1% level of significance to determine whether the cheaper batteries have a shorter average battery life. To test this hypothesis, the pricing manager installs 40 randomly selected batteries of the new brand in the company's walkie-talkies. He finds that the mean lifetime for the sample is 52, with a sample standard deviation of 10. Now, let's see what it is that he's trying to investigate. He wants to know, okay, so he's concerned that the new batteries may not last as long as the other ones. In other words, he is concerned that the population mean for the new batteries is less than 55. Remember, 55 hours was the battery life of the old brand. So the null hypothesis is always equality. How do we get our t-test statistic? Well, again, the formula is x bar minus mu divided by s over the square root of n. X bar comes from right here, a sample mean of 52. And what is the mean of the population, the mu? Remember, we always assume the null hypothesis is true. S is the sample standard deviation gotten from right here. And N, 40 batteries. So your t-value is negative 1.90. Now, how do you get your p-value? Okay, well, if you go onto your TI, and when you look at normal CDF, you're going to see something very similar called t-CDF. This is for the t distribution. The parameters are just like the ones that you would have for your normal CDF. Left endpoint, right endpoint. Then you have a third parameter. It's the degrees of freedom. Now, the degrees of freedom are the number of data points minus 1. So there were 40 batteries being tested, so the degrees of freedom is 39. So again, go to your, on your TI, you go to second vars, and then you're going to see the list of distributions, and you don't want normal CDF anymore. You want t-CDF. And that is your p-value. Well, in this case is 0.032, which, if we're doing this at the 1% significance level, is bigger than our alpha value of 0.01. So we failed to reject the null hypothesis. So at the 1% level of significance, there is not sufficient evidence to conclude that the mean battery lifetime of the new brand is shorter than the original brand at 55 hours. Okay, the next thing we're going to do is we're going to look at running a hypothesis test for paired data. Now, psychologists often argue over the best way to help people with anxiety. Two possible treatments are counseling and pharmaceutical treatments, in other words, medicine. Suppose a team of psychologists has recommended that people who experience anxiety attacks should receive regular counseling. The psychologist claims that counseling sessions provide a therapeutic or healing experience. The psychologists promote this type of therapy rather than pharmaceutical treatments. To test the effectiveness of counseling, a researcher randomly selects 6 people who experience anxiety attacks. These 6 people are interested in the counseling treatment. The researcher gives each person an anxiety test before and after the person has a counseling session with a therapist. Higher scores on the test indicate a higher level of anxiety. The test scores of the 6 people are shown below. At the 5% level of significance, can we confirm that the counseling sessions reduced anxiety? Assume the population of test score differences is normally distributed. Now notice paired data. 6 people, sample size of 6, and we have pre-counseling score and we have post-counseling score. Okay, now here, when we talk about mean, We're talking about the mean of the differences. Now, the order of subtraction is pre-counseling score minus post-counseling score. Now, the order of subtraction is post minus pre-counseling score. So remember, we're dealing with differences here. So what we're going to do is, in our TI, we're going to put in the following numbers. 64 minus 66, the difference, -2. Then in our TI, we're going to put in -6, 65 minus 71. Then in our TI, we're going to put in 79 minus 80, -1. Then we're going to put in 81 minus 78, which is +3. 81 minus 85, we're going to put -4 in the TI in our list. And finally, 91 minus 90, we're going to put 1 in the list. We're going to go back to one of our stats, and the sample mean is -1.5. The sample standard deviation is 3.27. To set up a hypothesis test, we're interested in seeing if the counseling relieves anxiety. If the counseling relieves anxiety, the post-counseling score should be lower than the pre-counseling score, which means the difference of the means would be negative. That is how they got the alternative hypothesis, mu less than 0. And again, the null hypothesis is equality. Next, we have to get our t-value, x bar minus mu. Now, x bar from the TI is -1.5 minus mu. The mu is from the null hypothesis, which is 0. S is from the TI over the square root of 6. The t-score is -1.12. This is a left tail test, so the p-value is tcdf, -1e99, -1.12. Degrees of freedom is sample size -1, 5.16. At the 5% level of significance, the 0.16 is bigger than the 0.05. Therefore, the p-value is high. We must be shy. We do not accept or reject the null or the alternative hypothesis. The evidence does not allow us to conclude that average anxiety levels are lower following the counseling sessions.